So today, my task was to talk a bit about the proposal toolbox, and that's the set of tools we have already available, or some of them will come available soon, to get ready and prepare for your JWST proposals. So as Pierre showed before, we have undergone and is about to finish the last cryo campaign for all the JWST instruments plus the mirrors, and then after that it will start the implementation phase of the whole sunshield and the entire telescope. The launch is planned for spring 2019, and the call for proposals, as Jeff has said already, it's November this year. So the telescope is getting ready, and we should get ready as well to submit proposals and kind of optimize our science cases. So there are already a set of tools that are available for preparing the proposals. And I would like to start first with the simulators, or the simulated data. So I will have links to all these in the last slide, so you can just go there and click the button. There are already some simulated data ready to go prepared, and they are available at the ESAC website, and those are for NIRSpec and for MIDI. And at the STSCI archive, the mass archive, there are simulations for all instruments that are ready to go. You can go download them and analyze them. There are two types of simulators. MIRISIM is about to be released, and it's a simulator that it simulates realistic data at a detector level for MIRI IFU, imaging, and low-resolution spectroscopy, and they are ready to go to be ingested by the pipeline. And this week we have here Pamela Klassen, who actually, she's there. She has a poster on MIRISIM. If any of you is interested in installing MIRISIM or having a demo with it, please ask Pamela, because there will be time for her to go through that. Jeff. Okay, so please talk with her. It's a very nice tool. It'll give you a very good feeling about what the MIRI data will be like, what can you expect from it, and how the pipeline will reduce it. Then we have STIPS. STIPS is, well, MIRISIM, sorry, is, again, imaging and spectroscopy. STIPS is a simulator at STSCI. It's about to be released, I believe. It will be before the Cycle 1 call for proposals. And essentially, it simulates for MIRI and NIRCam realistic stellar photometric fields using large field of view, something similar to this. This is a NIRCam simulation of 4 stellar clusters. And then we have the WebPSF. It's up here. And WebPSF allows you to simulate PSFs, obviously, JWST PSF for all instruments. So there may be situations in which you may want to have a reasonable good idea about how the PSF will be, so you can subtract it, how to face that in your science data. You have a simulator already that can do that for you, and you can use it. However, this week we are not going to focus on those tools. We're going to focus on more like hands-on preparation, so you should use for preparing your proposal. And there are a few of them. So the first one we want to talk about is ESA Sky. It's not really designed to prepare JWST proposals. It's a more broad tool. It allows to give you very quick and fast access to every, many spaced observatory, and you can download directly all the reduced data. On top of that, you can also display the JWST footprints, so that gives you a good, very quick assessment of whether your field of view it's fitting with your target. Do you need to do mosaic, etc. This kind of quick assessment. So then we have the target visibility tool. That's an STSCI tool that it allows you, again, these two are for more pre-preparation. When you're thinking about your science, what do you want to observe? Will you be able to observe it in this window of time? So the target visibility tool gives you not only the visibility windows throughout the cycle, but also it relates you with the position angle. Suppose you want to do chronography, or you want to observe a particular jet in a particular orientation. The target visibility tool will give you information on when that can happen, or if that can happen. It may be the case that some configurations are not possible in the time you want to do them. Then, actually, I'm getting ahead. Yeah. Well, then the exposure time calculator. I'll go through that later. And finally, the Astronomy Proposal tool, the APT. So again, here is a Sky. This is an example. And Bruno will give a demo this afternoon, I believe. And it's a very fast, very quick tool. It gives you access to a wealth of data that you can actually download, especially if you are interested in something like multi-wavelength, multi-mission science projects. This is a tool you can use. And this here is an example of the NIRCam footprint on your target that allows you to say, okay, do I need to cover the NIRCam gap? Do I need to mosaic? Do I want to do this or that orientation? You can do that quickly. Again, the target visibility tool, it's actually two different tools. One is the general target visibility tool that it works for essentially any object in the sky. And the other one is more focused on coronagraphy. We're going to have a coronagraphy splinter tomorrow afternoon, and I'm sure there will be discussed, and you can ask questions about that in there. Then we have the exposure time calculator. The ETC, it's really not, I would say it's not the standard ETC we are all used to. It's a more complex tool. It has a bit of a ramping up, but then once you're used to it, it's really flexible and allows you to do a lot of different things. And essentially, it calculates the detailed performance of all instruments, and it allows you to define different sources. And this is, for instance, a model of a source. You could define, I don't know, a galaxy in the middle with some clusters around. You can define lenses, stellar clusters, essentially anything. So there are many models. It's very flexible, and it's very powerful. And it gives you the signal to noise, not only for imaging, but also spectroscopically. So it works in 3 dimensions, detector and wavelength. And finally, the Astronomy Proposal tool. It's again developed at STSCI, and it's used to write, validate, and submit both HST and JWST proposals. If you're used to HST proposals, it's a little bit different for the JWST, and there will be a specific talk about this, giving you all the details. But essentially, in really a nutshell, APT uses a template approach. Template means that for each observing mode, you have a set of parameters. For instance, for MIRI imaging, you can use all the imagers with all the subarrays and readout modes. For NIRCam coronagraphy, you can use the specific configurations that have been defined. So you can play with these certain allowed parameters to build up your proposal, and you can also validate it and verify it and submit it. I have to say that anything you can check in the target visibility tool or ESAC has to be finally validated here. APT has kind of the last word as whether or not your orientation can be scheduled. So having said all that, this is a suggested path for working, and this is the path we are following up this week. So we have ESAC and the target visibility tool as starting point. You go, you check the target, you see how it fits with your idea, you see if it is schedulable or not in the orientation you want to do. Once you've done that, you go and go to the exposure time calculator and assess in a realistic way how long do you need to observe your target. Are you going to saturate? Do you need to integrate for twice as much as you thought you would have to do? That you do with the ATC. Once you're finished with the ATC, APT is a tool to go and insert all that information of your exposure time with the specific template that has been defined for that observing mode. So this week, what we are doing is, first of all, as Marco said, individual little presentations and demos, and then a small exercise that are meant to be educational, if you want, for us all to learn and to get familiar with the tools, and then finally do real science cases. This is, of course, not a linear process. You will have to iterate. So you may find that you go to the ATC, you have an idea of how to do something, and then it happens at the APT, I don't know, you are violating the data volume, or something doesn't work because your observations are too long and they have to be broken into visits. You will have to iterate this process, and in the meantime, you will have to, of course, go to the documentation. There will be the first tutorial this afternoon is about the JWST documentation, how to efficiently access it and use it. So with this idea, we think you'll have a kind of a solid background if you want to, in November, be ready for preparing your JWST observations. These are all the links. It was a very short talk because it's only meant to give you kind of an overview of the tools we're going to use this week. But if you have questions, please let us know.